All right, so welcome back. Today we're going to talk about special types of parallelograms. We're going to talk specifically about rectangle, rhombi, and squares, which are all part of the parallelogram family. I like to think of the parallelogram as the grandma or the grandpa. Okay, and then the rectangle and the rhombi are the mom and dad, and the square is the perfect love child of the two. So we're first going to look at the rectangle. So the rectangle should be semi-familiar to you. Most of you probably know that it has those four right angles. Um, that's something we would have learned in elementary school. It's also going to have all the properties of the parallelogram. So the opposite sides are going to be congruent. Okay, the opposite angles are going to be congruent. Same side angles will add up to 180, right? 90 plus 90 is 180. A lot of the times when we're looking at these problems, when they give us those right angles, they expect us to be using right triangles and mostly Pythagorean theorem. Okay. Um, And sometimes they'll want us to find part of the angle. So they'll tell us this part of the angle is 82 and ask us for that one. We know that the whole angle's 90, so we would just subtract 82 to get x, just like we would when we were doing complementary angles. The other quality we have is that diagonals are going to be congruent. That means the entire diagonal itself is congruent. So if I highlight this diagonal and this one, they're going to actually be equal to one another. So their parts are equal. So from A to R and R to C, those are bisected still. So they're equal, but they're also going to equal DR and RB. So all of those parts in their diagonals are going to be equal. And all we have to know there is that we just set them equal to each other. Just like sides, the only thing we can do there is set them equal. Then we have the rhombus. It again has all the properties of the parallelogram, the opposite angles being congruent, same side angles adding up to 180. What's special about the rhombus is that all of its sides are going to be equal. So that means each side is congruent to one another. Okay, which all we have to do is set each side equal. Sometimes they'll ask us for the perimeter, so we'll find the missing side and then add them all up. The diagonals are perpendicular, right? And when we hear the word perpendicular, we should really be thinking about the word 90. So when the diagonals cross, they form right angles. So all of those angles there are going to be right. And if we look, it creates 4 mini right triangles there. And again, we would solve that using Pythagorean theorem. We also need to remember from the fact that it's a parallelogram that DB does bisect AC. So AE is going to be congruent to EC and DE is going to be congruent to EB. That's a property from the parallelograms. It doesn't lose that. And the last property is that the diagonals are going to bisect the opposite angle. And remember, bisect actually means to cut in half, okay? And that means we're taking those angles and we're splitting them into 2 even parts. So if the entire angle was 22, the little pieces would each be 11. Okay, they cut them in half there. And finally, the last special parallelogram is the square. Okay, and the square, again, I say is the love child of the rectangle and the rhombus. And I say this because it holds all the properties of squares, rectangles, and parallelograms. So it's going to have the 90-degree angles in all the corners. It's going to have the 90-degree angles at the bisector. All the sides are going to be congruent to one another. All of the diagonal pieces are going to be congruent to one another. So it's just this amazing shape that is perfect, right? It has all of the properties. If you have any questions on any of these, please bring them, write them down on the side of your notes and bring them to class, and we can discuss them then. Please remember these properties are super important, and I do suggest writing them down and studying them with either flashcards or on Quizlet, where I have also placed the properties. All right, now we're going to look at a few examples of how we might use those properties to solve problems that they give our way. So here we're told that we have rectangle BASE, and they have the diagonals drawn in for us, and we're asked to solve for little a, which is in our problems, right? There's little a. EA and SB. So once we find little a, we're going to have to plug it back in to find EA and SB. You can see on the right of your notes, I left some space for you to talk about some of the key things. So please use that as we go through. So we're told that EA, this diagonal here, is 5a plus 4. And then we're told that SB is 3a plus 8. Now we're talking about a rectangle here, so the property we're going to use is that the diagonals are congruent. So I'm going to write diagonals. Oops, that should be an S. And then congruent. I forgot. That's why I don't teach English, right? Diagonals. All right, congruent. So that's the property we're using, is that the diagonals are congruent. And so we're just going to set them equal, because congruent means equal. So 5a plus 4 equals 3a plus 8. And we're going to subtract the 3a to the other side. We get 2a plus 4 equals 8. And then subtract the 4. And 2a equals 4, or a equals 2. Since I already have it written there, I'm just going to write it at the bottom. A equals 2. And again, now with my 2, I just really have to plug it back into one of them. I'm going to plug it back into the 3a plus 8. So I got 3 times 2, which is 6, plus 8. And I'll get 14 for both EA and SB. Remember, they're equal, so I don't have to plug them into both. But you can to double check that you've done your math correctly. So 5 times 2 plus 4 gives us 10 plus 4, or 14. Notice that they both indeed got 14. Again, if you have any questions on this, please circle where you got confused, or write a question on the side and we can talk about it in class. The next example that we're going to look at is talking about a rhombus. So we're thinking about the properties of a rhombus and the properties of a parallelogram. Okay, they tell us that we are solving for y, GO, and OL. So GO is this side, and OL is this one. Okay, and we know that GO is y plus 1, and OL is 2y minus 5. The property that we're going to use here, right, if it's only on the side length, so we're going to use that all sides are congruent, right? All sides congruent. Okay, and if all sides are congruent, it means they're all equal. And remember, all we can really do with sides is set them equal. So even if you can't remember the properties, if you're given two sides, all you can do with them is set them equal to each other. So y plus 1 equals 2y minus 5. Subtract y to both sides. 1 equals y minus 5, and then add 5 to both sides. So we get y to equal 6. And now we have our value, so we're just going to plug it back in. So we get 6 plus 1, which is 7 for GO. And then again, OL should also equal 7. But if you want to double check, just plug it back in. So 2 times 6 minus 5. We have 12 minus 5, which also gives us 7. Again, if you have questions, please ask. Feel free to pause the video here and go back and take your time and solve it and see if you can get it without me walking through the steps with you. All right, so example number 3, I'd like you to please try on your own. This is a square, and they give us angle CRS. So CRS and ORS. They tell us this one is 4x plus 5, and this one is 3x plus 15. So please pause here and see if you can figure it out. Okay, so here we should have used that diagonals bisect the angles. You could have also used the fact that you knew that squares had a right angle, and if you cut a right angle in half, it's 45. So you could have also done 4x plus 5 equals 45 um, and solved. And I realized I wrote 40 here when I should have wrote 45 because I got 45. So we found that x equaled 10 because we just set the two angles equal to each other. And then we plugged in to find the angles each. And again, you could have also done the fact that you knew the angles were going to be 45 because it is a 90-degree angle that you cut in half. The last example we're going to do today asks us to label the rhombus, which it's already done, and draw in the diagonals intersecting at point A, which we have here. And we know that the measure of ATK, so ATK is x plus 10, and we know that ATB is 4x minus 35. So if you could pause the video here or maybe take some time and see if you can figure this out. And again, I will show all the work in just a few seconds. Okay, so here was the same property that we used with the square. It was that diagonals will bisect the angles. And so we just set the two equal to one another and we solve for x. And then once we get x, we plug it back in. I chose to plug it into the x plus 10 because I knew that math would be easier for me. And I found that the angles would be 25 degrees. Now we could take this a step further. And if we know that angle T down here is 25 plus 25, which means it's 50 degrees, right, for the whole angle T, we could find angle B, right, because they are related with 180. So it'll be 180 minus the 50, which would give us 130. So the entirety of angle B would be 130. Now, if we wanted, again, to find the parts, the little half parts, we would divide 130 by 2 in order to figure out what these two angles would be. And if we did that math, we'd find that each angle was 65 degrees. Okay, so those are a few things we could do there with that. Now, if you have any questions, please feel free to mark it on the sides of your paper or maybe on a separate sheet of paper. And we can talk about them in class where we're just going to do lots of practice with these properties. Hope you have a great rest of your day.